Yep.
Yeah, just wait. Okay. Who are we? RSM. I'm Seth Johnson with RSM. Today we're going to be going over talk about attacking Active Directory, and just sort of an agenda. We'll kind of kick everything off, introduce ourselves, and then kind of do a general pen testing overview, and kind of walk through the methodology that we use when attacking Active Directory environments. So we are a consulting company, and a large majority of our clients do leverage Windows environments. So attacking Active Directory is very fundamental to our jobs. So we'll just kind of kick it off, introduce RSM, who we are as a company, and all that. So just a general overview of like who RSM is. Basically, we're an audit, tax, and consulting company. So those are three sort of business units. We are under the consulting company, or consulting business unit, I should say. And our focus is on security testing. So we kind of run the whole gamut: web app testing, network pen testing, social engineering, stuff like that. RSM as a whole is an international company. We have offices all over the US. We're actually the largest firm in the world focused on the middle market. So we sort of go after not necessarily small businesses or Fortune 500 companies. We do have some Fortune 500 clients, but primarily focused on the middle market. So that's kind of our key client focus. You can just see kind of a map of US locations. A lot of locations in the Midwest. RSM was actually used to be called McGladrey. Maybe some of you guys might be more familiar with that name. But it was actually founded in Cedar Rapids. So it's big Iowa focus. But we also have offices, as you can see, all across the US, as well as internationally. So if you guys ever are interested in working overseas or in Europe or wherever, we have offices all over. So. Just to kind of go over general introduction about the presenters. I'm Seth Johnson with RSM, been with RSM for about 2.5 years, focused on kind of like I said, pen testing, social engineering, that kind of stuff. Based out of the Des Moines office, and work with these three hooligans. So.
I'm James Curbo. I handle his big brother. I'm an associate. This is my first year with the firm. I graduated from the University of Northern Iowa. Yeah, that's just a little bit about me.
I'm Nick Losby. I'm also an associate with the firm. My handle is Blake Duss, and I graduated from ISU this May, and I was a former IASG member.
My name's Ellis. I'm also a new hire, worked with Nick as an intern. KU grad. I attended all of the CDCs at Iowa State, that kind of thing. Basically, Nick went to Spear.
Thank you. Yep. So a little bit about what we do as consultants. Primarily, most of our work is consulting based. So RSM has clients. Those clients want us to do pen tests or social engineering. So then we come on board on the project and we communicate with the clients during the project and work with them throughout the entire process. We run the gambit as far as pen testing. We do internal pen tests, externals, web apps. We do mobile pen tests, physicals, red team assessments, social engineering, phishing, you name it. Today our discussion is going to be focused mostly on internal pen tests and specifically Active Directory type attacks. That's a huge part of what we do on internal pen tests, so it's an important concept to cover. Our engagements range anywhere from a week to multiple months. On average, it's about a week long, maybe a week and a half, depending, but it just varies. The amount of travel you do is also going to depend on what kind of engagements you're doing, knowing where the client's at, what the client wants, if they want you on site, if it has to be done on site, things like that. What we do is very technical work, but considering we're still working with the clients throughout the entire process, we still need to be able to communicate. So while it's great to work on your technical skills while you're still in school, also realize that communication is very key in what we do. So just to distinguish, give you an overview between red teaming and penetration testing. Red teaming, you're simulating an adversary from the outside trying to stealthily breach their target without being caught, focusing on exfilling data, sensitive information, PII, health data, things like that, demonstrating how an advanced adversary could get in and hurt your company. Usually only one single path to the target, heavily focused on detective control. So are our clients able to detect when an attack is occurring? Are they able to detect when they're on the internal network? Versus a penetration test, we are testing their network and applications to find vulnerabilities, misconfigurations, default weak passwords, things like that. The engagement's typically shorter. There could be multiple exploit paths to domain compromise. There doesn't have to be just one. We try to find as many as we can. It's not uncommon for us to find more than 5. Heavily focused on preventative control. So are there EDR and antivirus and Defender picking us up? Are there IDS detecting us? And are there IPS preventing us? But again, both of these allow us, we need to think like an attacker, and how can we abuse functionality that is legitimate into doing things that we want them to do. So while we discuss various attack paths to get full domain compromise or compromise on one specific system, please do not do anything that we show you here on anything that you do not own. Only do this on labs that you have strict permission to do these tests on.
Right, so quick overview of the actual pen test methodology, basically. So we do our recon, and then we get our initial compromise, then we try to expand those credentials or compromise, and then we want to target the rest of the enterprise. So if there's multiple domains, we want to compromise both of the domains, and then we want to establish persistence, and we want to exfil data. So just going through that. So first, what is Active Directory? Well, Active Directory is the management service developed by Microsoft to manage Windows networks environments. This is awesome. It gives super granular control over specific things. If you wanted to, through group policy, you could disable a user opening Internet Explorer, or you could disable opening Calculator if you want. It provides a central authentication and management for users, computers, and groups to allow you to do all of that. And domain services is the service of Active Directory that stores information about the domain and makes it accessible to users and administrators. And domain controllers are the actual servers that are running the Active Directory domain service. So why have a domain controller? Every part of Active Directory authenticates against the domain controller. This obviously makes it a target for us. It controls all the security policies pushed to each system through group policy, as previously mentioned, and it controls trust between multiple domains, as well as many other functions. It can run a web server, it can run, it runs Kerberos, and this opens it up to a whole bunch of attacks. And some of the attacks on the domain controller that we usually do are dump hashes, see if there's any clear text passwords in memory. Sometimes we use a silver or golden ticket, and then there's also a fancy attack called skeleton key. So what are domain trusts? It allows users from other domains to access domains from other domain controllers. So you're on domain A. If there's a domain trust for domain B, then the user on domain B can use domain A's resources, basically. Companies need to use different resources, specifically different branches are usually their own domain. So if you have a branch in Cedar Rapids, Iowa, and you have a branch in Ames, those are usually 2 different domains. Sometimes that's a generalization. But yeah, with PCI compliance, it is highly recommended that there's some form of separation between the card holding domain and the corporate domain. PCI stands for payment card industry, so anyone who processes or uses or stores credit card data, they fall under PCI. So footprinting and enumeration. So you walk into a bank, you plug in your laptop to an active network connection. What's next? What do you do? First, you find out what the network looks like. What's the IP of your laptop? Did you get a DHCP lease? Do you have to set a static IP address? What network range are you on? What open ports are around you? You can use Nmap and Mascan to find that. What else is on the same subnet? Can you open Wireshark and see anything in plain text? What open ports are there around specifically dealing with web pages? Can you find the default port for a printer potentially? And you can use iWitness to automatically take screenshots. So Mascan is really awesome. It's super fast. Nmap is the tried and true method, but Mascan is significantly faster. You can map an entire it actually was designed to scan the entire internet in under a day. And that's very possible, and people do it every single day. So initial compromise. Getting your first foothold on a network can be the most difficult part of the attack. What can you even do on a network without credentials? Surprisingly, a lot. You can do looking for null or guest or anonymous sessions, man-in-the-middle attacks. And by that, I mean you can answer certain network queries, you can advertise yourself as a router, and sometimes you can intercept plaintext protocols. And in those protocols, you're able to see certain things that could include passwords. If there's a printer on the network that you found using iWitness, try and use password spraying or see if there's any default credentials on it. And in addition, if you're in Computer E231, then you know about MS-1710 or MS-0867, and those are remote code execution exploits, and so you can try those. So for null guest or anonymous sessions, SMB allows for empty or null sessions, and access over SMB implies that you have credentials. So let's say the domain controller has null sessions enabled. What can you do with that? Sometimes you're actually able to dump the password policy, so you can see what minimum password length is there. So you can see if it's 8 characters or if there's complexity enabled. You can pull the domain you can pull the FQDN, the fully qualified domain name of the actual domain itself, and that'll help you with your recon later. So Windows, the operating system, has a built-in local guest account. Usually it's disabled. It's still nice to check if guest sessions are allowed. And sometimes the Windows domain itself allows that guest account as a domain user. I have seen that somewhere, and that was pretty bad. It let me basically be a user on a computer with 0 authentication whatsoever. And FTP can be configured for anonymous access. And end of the day, really easy, just to share C/ over FTP. And so if you're running as the specific user and they have passwords somewhere, like in C users jsmith desktop passwords.xlss, you can get that over FTP. So man-in-the-middle attacks, specifically multicast protocol response poisoning. So this is link local multicast name resolution. Try saying that 3 times fast. It is enabled by default with no security or authentication component. Basically, if you look in the diagram, a victim computer asks who is file server, and the domain controller, or DNS server sometimes, they're usually the same server, responds back, I don't know. So then the victim broadcasts out to the subnet, hey, is anyone here file server? And us being attackers, of course, say, yes, we are. Please authenticate to me. Please encrypt this nonce with your password hash. So it encrypts a nonce, sends it back to you. Since you know this nonce, you can then try and decrypt that encrypted response. And if you are able to find the correct key, then you know it's derived from the password, and therefore you have their password now. And a tool to do that is Responder, and then Hashcat and John the Ripper for cracking them. You can also just tell everyone that you're a router. This is called Man-in-the-Middle 6. So when Windows connects to a network at login, you remember the little pop-up, do you trust this network, yes or no? The answer is always no, by the way. So Windows, since Vista prefers IPv6 by default, and most networks only hand out IPv4 leases. So if you tell every single Windows computer around you, hey, I'm a router, here's your IPv6 lease, it'll automatically prefer it and automatically connect to it. Windows then, at login, will ask for proxy information. It'll query the network itself, hey, is there a proxy on here? And we, of course, say yes, it's me. And we serve them an HTML document with an image that is pointed to us over SMB. Well, SMB implies credentials, so they authenticate to us over SMB, and now we have their hashes as well. We go through the same step, hey, encrypt this nonce, send us back the encrypted response, and if we're able to find the key for it, we know their password. But do we even need to crack them? net Ntlm v2 hashes are kind of slow to crack compared to Ntlm or NT hashes. So why crack the hashes when you can just relay them? You unfortunately cannot relay from origin machine to origin machine. And really quick, what is Ntlm Relay? The server says, hey, this is admin, I like to log in, and we are in the middle, and we say to a different target, hey, I'm admin, I want to log in. So then we tell the original victim, encrypt this challenge that the target gave us, and then we just forward it back to them, and they tell us access granted, and then we tell the victim machine access denied. So now we have access to it, but the victim machine does not. So since those hashes are coming in over HTTP, we can relay to a service that accepts Ntlm authentication, which is SMB. SMB allows it as long as SMB sign-in is not set to enforced. And so the tool for that is Ntlm Relay X. So if you combo man-in-the-middle 6 plus Ntlm Relay X, it's amazing, it's fantastic. I got domain administrator in 10 minutes. Like it's insanely powerful. Man-in-the-middle 6 brings in the connections by the proxy method, and then Ntlm Relay X just relays the hashes and dumps secrets, as long as the relayed account has permission to do that. And what happens if the account being relayed is a computer account? Come back for part 2 of the talk.
So, more on man-in-the-middle attacks. We'll kind of keep getting into that. They're not just all relay attacks, pretty straightforward-wise. You also kind of have to think about encryption. And not all of these protocols are done over secure encryption. So things like FTP, Telnet, HTTP, they're all sent in the clear text. So if you're using a tool like Wireshark, you'd be able to essentially just pull off all of that information and decrypt it immediately. Pretty straightforward. So this is honestly one of the huge ways that we compromise networks is just default and weak passwords. Usually we kind of go by the mantra of like, well, you can secure everything you want, but you can never secure a dumb user. And so what makes a good password? And it kind of gets to the point where originally, a long time ago, it used to be use an 8-character password. Well, password fits that bill. Is that a good password? No. And so you kind of want to escalate your password, and generally we recommend more than 8 characters, complexity enabled, that means numbers, special characters, etc. And then never reuse passwords and change it every 90 days. So if that isn't done, this leads to predictable things. So for instance, on engagements, if we crack a password of a user and their password is like password 1234 exclamation point, and then we crack that, they realize it and they change it, it might, we can kind of use that password to kind of gauge it, like maybe it's password 1234 $sign. And so it leads to a bit of predictability within that. So passwords are kind of always a big issue in our engagements. So yeah, and the big thing is change it every 90 days, because if you get compromised within that 90 days and you don't end up changing it, then you have access for a very long time. And so that also leads to interesting little patterns like using seasons, like winter 2019, summer 2019, winter 2020. And so kind of leads to that predictability. Yeah. So usually at this point, if we haven't gotten a foothold, at this point we kind of do what's called password spraying. You guys might know what password brute forcing is. That's where you essentially take one user and you try a bunch of different passwords against that user. Well, they have, especially in things like Active Directory, you can hit lockouts. And that's essentially like if the same user tries a password 5 different times and it fails each time, then it will lock out that computer and not allow it to log in at all. And we as attackers don't want to do that, because one, that can disrupt company operations, and that's really bad. Also, it can give us away. So instead we try things like password spraying, and that's trying the same password across a number of different users. So if we know that there's 50 different users, we can try winter 2020 or password 123 against all of them, and hopefully one of them might have a default password. And so we tend to spray things over SMB and Kerberos as well, using a variety of tools like CrackMap, Impacket, Metasploit, and Kerberos. So.